Hi everyone, these notes are on applications of quadratics. We are still in Unit 4 and this is page 17 of your materials for Unit 4. And so these applications are the end of the unit, and this is the whole reason that you had to learn graphs and learn how to find solutions and x-intercepts and all that good stuff, was so that we could apply everything that you learned from the graph of a quadratic to some actual real life examples. So I'm going to go through these examples on page 17 and on page 18 with you, and then you'll be able to do the rest of the problems in the packet and then start reviewing for your quizzes and tests. So, number 1, a small independent motion picture company determines the profit P for producing N DVD copies of a recent release. And so this function represents the profit. P is the profit. N stands for the number of DVDs. Okay? And so P is measured in thousands of dollars, and N is also in thousands of units. So when we get our answer for N, it's actually going to be in thousands. So part A, how many DVDs should the company produce to maximize profit? Now, you've seen this word that looks a lot like maximize. It's a maximum. And where have we seen the word maximum before in this unit? Well, we've seen it when we were talking about a vertex. Remember, your vertex can either be a maximum or a minimum. So, to find a maximum for this particular problem, I'm not going to make you graph these by hand. I'm going to show you how to graph them in the calculator and find that maximum point. Okay? So, we're going to get the graphing calculator out. I'm going to kind of try to zoom in on it for us. Hopefully that'll show up pretty decent. And readjust. Okay, so we're going to go to y equals and clear out whatever's there. And we're going to put in your profit, which is negative 0.02 x squared. Ours is n, but we're going to put in x. And then plus 3.40x, and then minus 16. And we're going to graph that function. We're going to let the calculator graph it for us so that way we can find that maximum. Now, my calculator was set on an old window, so I'm going to go zoom standard and see what that looks like. Alright, so still looks like a line. It's supposed to be a parabola. So that means I'm going to zoom out. So go down, go to zoom, and then go down to choice number 3 and hit enter 2 times. Still see a straight line. Okay, well, let's hit zoom out again. Hit enter again. There we go, finally getting that shape. And so that's exactly what you're going to need to do when you're doing these application problems. If your graph doesn't show up, 9 times out of 10, you need to zoom out, because probably you're working with really large numbers. In this case, remember, our profit and our DVDs were in thousands of dollars and thousands of units. So it's going to be big numbers that this graph is going to represent. So you're going to have to zoom out. So just remember that. If you can't see your graph, don't panic. Just zoom out a couple of times and then it'll eventually show up. Okay, so now, since you've gone through all of the steps by hand and you understand, hopefully, how to find a vertex, I'm going to show you how to find it on the calculator. Okay? So, pay close attention because this is really useful information for when you're checking your work on a test. So, everybody can agree that this is your vertex. It's up here somewhere. It's a maximum because it's up at the top of the graph. The graph is face down, so the vertex is a maximum. So, in your calculator, you're going to go second and then trace. And then look at the choices that you're given. You have value, 0, you've got minimum, and you've got maximum. So Pick number 4, maximum. So then the calculator asks you some questions. It says left bound. That means it wants you to put your cursor, use the arrow button. Okay, so put your cursor somewhere to the left of where you think the vertex is going to be. So I'm going to say like right there. And then your calculator is going to say right bound. So that means you need to arrow over and put your cursor somewhere to the right of where you think the vertex is going to be. Okay, just to the right of it. Hit enter. And then your calculator says guess, and sure, we wanted to guess and figure out the maximum for us. So enter one more time for you, and
it gives you the vertex. So you've done all of that work by hand earlier in the unit. Now you can be rewarded for knowing how to do it in the calculator. Okay, so the maximum is 85. And it's 85, 128.5. Now this is important that you understand what each of these numbers stand for. The x value in this problem goes with the x in the equation, and originally it was an n. And remember, n was in thousands of units. It was DVDs. So when you look at your graph, the answer for x is going to be number of DVDs. Excuse me. Then the number for y represents the profit, and this is in thousands of dollars. So the y answer is the profit, the x answer is the number of DVDs, and both of them are in thousands. So when we go back to answering the question, it says how many DVDs should the company produce to maximize profit? So, how many DVDs? That's your x coordinate, okay? And then we had 85. Remember, we were like about 85.00001, lots of zeros. So, we're just going to round to 85, and it's actually 85,000. So, it would take 85,000 DVDs to produce a product, or I'm sorry, a profit. And then for part B, what will maximize the profit? Well, or what will the maximize profit be? So it's asking you what the actual profit would be. That's your y answer. Excuse me. So we look at the y coordinate of the graph, and so that's 128.5. That represents your profit. So it would be 128,500, and this is in dollars. So the number of DVDs would be 85,000 DVDs, and the profit for selling that many or producing that many DVDs would be $128,500. And we got that from finding the vertex of the graph. Okay, and it was a maximum, so that's why we found that spot right there. Okay, so that's basically how you're going to do a lot of these application problems. You're going to look for a keyword, and then somewhere on the graph is where that keyword is going to match up with. In this case, we were looking for a vertex because they were asking us to maximize. Okay, let's look at number 2. A local nursery sells a large number of ornamental trees every year. The owners have determined the cost per tree for buying and caring for each tree before it is sold is C equals, and then that would be 1/1000th n squared minus 0.3n plus 50. In this function, C is the cost per tree in dollars. So it's the amount of money that they're going to spend on each tree, and n is the number of trees that they have in stock. So for part A, how many trees will minimize cost? So you want to figure out how many trees need to be sold in order to have the least amount of cost, for it to be the least expensive to run this business. So you've seen this word,
it's been minimum. That's the word it's been. Instead of minimize, it's been minimum. And so a minimum also means you're looking for a vertex. So to look for a vertex, we're going to put this in the calculator and graph it and find that minimum. All right, so where's my equation? Here we go. So we're going to put this into the y equals 0.001 x squared minus 0.3x and then plus 50. You should put this in your calculator too so that you can follow along with me. And if any time I'm going too fast, go ahead and pause the video and catch up. All right, so we're going to hit graph. And okay, not so exciting, but we can zoom out again and hit enter again. There we go. That looks good. Just so that we can find that minimum point, which looks like on the parabola, it's going to be down here. So we're going to go second, and then we're going to go to trace, and you want to hit number 3, minimum. Okay? All right, now the calculator is going to ask you the same questions as it did for maximum. So you want to go a little bit to the left and hit enter. And then we're going to go a little bit to the right. I think it dips down, starts to go back up. I'm going to go right there just to make sure I'm on the right and hit enter. And then hit enter one more time. And there you go. It gives you the minimum. So the x coordinate is 150. The y coordinate is 27.5. So remember, x stands for, let's go back to the word problem. X stands for, or N stands for, the number of trees, and C is the cost in the trees. So for us, we don't have a C, we have a Y right here, and instead of an X, instead of an N, it's an X. Okay, so that's really a Y right there. So for ours, you can see that X is going to be 150. So X is the number of trees. It's going to be 150 trees that will minimize the cost. And then to find the minimum cost per tree, you take the Y answer right here, which is in dollars. So if it's 27.5, it's going to be $27.50. So what does this mean when we look at the word problem? It means that a local nursery is going to have to sell 150 trees in order to have the least amount of expenses for their business. And that cost per tree is going to end up being $27.50. If they sell less than 150 trees, then their cost is going to be more. If they sell more than 150 trees, they actually also have a cost that's more than $27.50. This parabola represents all of the different possibilities for each number of trees that the nursery sells. So over here still has a greater cost, and over here the cost still goes up. This spot right here is where there's going to be a minimum, so the least expensive amount per tree. Okay, so number 3, let's look at this one. The Gateway Arch in St. Louis was built in 1965, and it's the tallest monument in the United States. The arch can be modeled with a function. It looks like a parabola. Okay, so your arch basically looks like this. Okay, so X and Y are feet. So Y represents the height, X represents the distance across. Okay, so how high above the ground is the tallest point of the arch? Okay, so if you have an arch in the shape of a parabola, the highest point is going to be in the middle, right? Because that's going to be where the arch starts to come back down again. And so that's going to be your maximum. we're looking for the vertex again. Okay, so we want to figure out how high above the ground that is, like what that distance actually is. And then we want to figure out how far apart are the legs. These are the legs of the arch. So we want to figure out this distance next. Okay, so for part A, we need the height. And for part B, we need the distance across. All right, so let's put the equation into the calculator. So y equals negative 0.00635 x squared, and then plus 4x, and hit graph. Okay, there's your arch. That does a pretty good job like that. I don't think I need to zoom out again, so I'm going to go with that. We want to figure out how high above the ground is the tallest point. So the tallest point is going to be right there. We're going to look for the vertex. So second, trace, go down. This is a maximum in this case. We're going to go a little bit to the left, so we'll say like right about there, and then go a little bit to the right, which is over here, and then hit enter. And it tells us that the maximum is 314.9, comma 629.9. So if I rounded to the nearest whole number, which is fine for this problem, let's say this is 315 and this is about 630. Okay, so the y coordinate is how high this vertex is. So it's actually going to be 630 feet high. So this question mark right here, 630 feet. That's your height, because that's your y value on your graph. Now, the x coordinate for this is how far you had to go over to get up to that point. So from here to here is 314, like just over to the middle. So let me put that on my piece of paper. This distance right here, this is 314. Or if we round up, it should be 315. So you go over 315 and you go up 630 to get to that point. Okay? So the question in part B is asking, how far apart are the legs of the arch at their bases? Well, if this is one base and this is the other base, I call this base 1, we call this one base 2, the distance across is going to be 315 plus another 315. So 315 plus 315 is also 630 feet. So the answers to both of these are 630 feet. The height is going to be 630 feet, and the base will also be 630 feet. Okay? Okay, got to make sure that you read your questions carefully and draw a picture for yourself if that helps. All right, let's do number 4. The height of a batted ball is modeled by the function given, where x is the horizontal distance in feet from the point of impact with the bat, and h is the height of the ball in feet. Okay, that should be a period right there. All right, so part A, what is the maximum height that the ball will reach? So maximum, that means you're looking for the vertex again. And then part B, at what distance from the batter will the ball hit the ground? So let's think about this. If the ball's being hit, we'll say we've got somebody right here and the ball's being hit like that. So there's always a little bit of arch on that. No matter how far it goes out, there's still always a little bit of an arch. It's going to follow the shape of a parabola. Okay, so this is the ground. And then this is the path of the ball, also known as a trajectory. Okay, so it follows the shape of a parabola. So we want to find that maximum height. The maximum height is going to be somewhere here. Okay, that's your maximum height. So let's put it into the calculator. We have, let's see, negative 0.01 x squared plus 1.22x plus 3. Okay, let's hit enter. Okay, so I'm so zoomed out that I might need to zoom in, because the only part that we care about is that little part right there above the x-axis. We don't care about this negative stuff. We only care about when the ball is above the ground. These spots right here on the parabola are actually as if the ball would be like underneath the ground, and that doesn't really happen. Not at any baseball game I've ever seen. So we're going to go zoom standard and see what that looks like. Okay, looks like I should zoom out. So zoom number 3 and hit enter again. Okay, one more time. Zoom out one more time. And the more that you do these problems, the faster you'll get at getting nice graphs. So this is good. So right here, we're looking at just the part above the x-axis. That is the path of the ball. Okay? Now think of the ground as the x-axis. The path of the ball is the parabola, and the x-axis is the ground. So the maximum height occurs at the vertex. So second calc, go down to maximum, and then we want to hit enter, and then we want to hit enter over here, and one more time. There you go. So that's happening at 61, 40.21. So remember, we want to think about what these variables mean. The x is how far it goes out, and the y is how far it goes up. So we want to know maximum height. That means we want this y value right here. So your answer to part A is going to be the 40.21, and that is labeled in feet. For part B, at what distance from the batter will the ball hit the ground? Okay, so here we are again. Okay, so if we had to go over 61, okay, and I'll put it on my picture, I had to go over 61, and then I had to go up 40, okay? So over 61 and up to get to this point. How far would I have to go to get back over to the ground? Because right here, this spot, this x-intercept, that's where the ball hits the ground. Goes up here and then hits down here. Well, remember that if this is the middle, then that means the axis of symmetry goes down through the middle, and a parabola is the same on each side. It's symmetrical. So if it's 61 on this side, it's also going to be 61 on the other side. So we can put a 61 right here. So how many feet away from the batter does the ball hit the ground? Well, it's going to be 61 plus 61, which is a total of 122 feet. Okay? So at what distance from the batter will the ball hit the ground? It's going to hit the ground at 122 feet. Okay? So I'm going to do another video on the ones on the back. Let me know if you have any questions. Thanks.